In today's notes, we learn a way to prove that we have right angles given congruent triangles. That's the essence of what we're calling today the right angle theorem. And here's what it says. It says if two angles are both supplementary and congruent, then they must be right angles. And let's think about why that's true. Now, if they're supplementary, that means we know that they're going to have to add up to 180 degrees. If they're congruent, we know that they're the same. So if they're both x, I'm going to take x plus x and set it equal to 90. X would have to be, set it equal to 180, x would have to be equal to 90. Now, it's been a long time since we've had to actually show in our proofs that we have supplementary angles. So at this point, really what we need to show in our proofs is that we have congruent angles, and just know that they're next to each other, which means they're going to form a straight line. So we don't need to state the supplementary in our proof, but know that they do need to still be supplementary. So here's how it's going to work in a proof. So we're given that triangle NOE is isosceles with base OE. So here's our base, OE. Having that information tells us where the congruent sides are. So if this is isosceles, that means that NO is congruent to NE. We also know that NT is a median to segment OE, which means that OT is going to be congruent to ET. From the reflexive property, we can show that NT is congruent to itself. So it looks like I have enough information to show the triangles are congruent. I'm going to go ahead and do that. So I'll start off with NO congruent to NE. And the reason I know that is because I have an isosceles triangle. So I'm going to say that an isosceles triangle has two congruent sides. Then from there we said that OT was congruent to ET. And that's because a median cuts a segment into two equal parts. And then from there we said that NT was congruent to itself by the reflexive property. So at this point we have enough information to show that the triangles are congruent. So I'm going to label these S, S, and S so that I know that the triangles can be congruent. So I'm going to go ahead and erase this part because I think we've got that down pat. And then we can get into how do we show that we have right angles. Now if we knew it was perpendicular or we knew we had an altitude, that would be a very easy operation for us to do. But in this case, it's a little more complicated because of the fact that we don't have that information given to us. And we can't assume altitudes or perpendicular or anything like that. So we're going to say that the triangles are congruent. And that's because of side, side, side. We've got three sides that are congruent. Now we're going to pick out the pieces. So if you look at angle NTO and angle NTE, these are these angles right here. Together they form this straight line OE. And that's important information because that means that angle NTO and angle NTE are going to be supplementary because they form a straight line. Now the right angle theorem says if I can show that they're congruent as well, then I've got right angles. So I'm going to say in my next step that angle NTO is congruent to angle NTE. And if I just prove triangles congruent and I'm picking out the pieces, that's called CPCTC. We just proved that these are congruent. We already knew they were supplementary. So in our next step, we're going to say that angle NTO and angle NTE are right angles. And we're going to use what we're calling the right angle theorem. So we're going to abbreviate that. RAT for right angle theorem. If you want to, you can also short it like this, show the right angle, and then theorem. Your choice. But the main idea here is we're not going to have to prove the supplementary. We can see that from the picture that they are. We are going to have to show that the right angles are congruent. And so once you have them congruent, then they must be right angles because of the right angle theorem.